combinations. They are similar to the permutations we've already talked about, except that in this case, order is not important. We're just selecting a group of objects. We don't care which one was chosen first, second, third, or fourth, just what objects were chosen out of the total number of objects. So the formula will look similar to that of permutations as well. Instead of the P, we use the C for combinations. N is still your total number of objects. R is still the number of objects you're selecting. So NCR, when you see that, you should recognize that means you're finding the number of combinations. And so the formula is n factorial divided by r factorial times n minus r factorial, because you're dividing out the order with this r factorial, because we don't care about the order. So that's what's new with the combinations formula. We take out all of those cases where you're selecting the same things but in a different order, because we don't need to know the order, just what objects we selected. Let's take a look at some examples. Number 1, if there are a possible 59 numbers and the lottery officials draw 6 numbers, how many possible combinations are there? So with the lottery, we don't care what was selected first, second, third, or fourth, just what numbers were chosen. So there's 59 total numbers, and they're going to choose 6 of them. So if we plug this into our formula, we do n factorial, so 59 factorial, over r factorial, so 6 factorial, times the difference between n and r factorial. So 59 take away 6 factorial, and so we get 59 factorial over 6 factorial times 53 factorial, which means everything below 53 divides out, so you could think of it as 59 times 58 times 57 times 56 times 55 times 54 over that 6 factorial, and you could enter it that way, or you could type it just how you see here. But at any case, no matter how you type it into your calculator, if you enter it correctly, remember you're going to need parentheses around your denominator to show that all of that is in the denominator. You should come out with 45,057,474 different possibilities. So that's why your odds of winning the lottery are not very good. Number 2, a college football team plays 10 games during the season, and how many ways can it end the season with 5 wins, 4 losses, and 1 tie? Okay, well, so for the wins, we'd have to take those 10 games and choose 5 of them. We also want 4 losses, and this is an and case. We want all of this to happen at the same time, essentially, in the same season. So we also need 10 choose 4, and we're going to multiply because we want it all to happen together. Then from those 10 games, we also need to choose 1 of them for a tie. So you could do the formula 3 different times, but there is an easier way. Let's take a look at how to use the features of your calculator. It does have the combinations formula stored inside of it, so let's take a look at those keystrokes. Okay, so here on your graphing calculator, you're going to come and hit the math button right here on the left-hand side, and that's going to bring up these menu options. You're going to go over to probability, the PRB, so I'm going to hit the left arrow to just go over, jump all the way over there. You could hit the right arrow 3 times, however you want to do it so that you can get over to this menu. And you see all of these different options. We will use 2, 3, and 4 for the most part. So you've already done option 2 for permutations, and you've done option 4 for the factorial, so now it's time to choose option 3. But before I do this, I actually need to enter my total. So for that first example, it was 10 choose 5. So I'm going to enter the 10. I'm going to go to math, over to probability. I'm going to choose option 3 for NCR. I'm going to enter the 5, and it's going to give me 252. for the next one, it was the 10 total games, so I entered 10. I go to math, over to probability, choose NCR. I wanted 4 losses, so I entered 4, and I get 210. And then I want 1 tie, so out of the 10 games, go to math, over to probability, choose option 3 for NCR, choose 1 game to tie. We get 10, and then I need the product of those. So I can just multiply 252 times 210 times 10, and I'll see that there are 529,200 ways that could happen, that we could win 5 games, lose 4, and tie 1. Your calculator is pretty powerful, so you could have entered it all together. You could do 10, choose 5 times 10, choose 4 times 10, choose 1, and you'll get the same answer that way as well. So you have some options, but just remember when you want these probability formulas and the factorial, you come here to the math menu, and then it's the PRB, so you scroll over to that. And again, in this course we're focused on permutations, combinations, and factorials. Okay, so our answer that we came out with then, we'll record 529,200 different ways that could happen. Okay, so example 3 says Mr. Jones owns 4 pair of pants, 7 shirts, and 3 sweaters. And how many ways may he choose 2 of the pairs of pants, 3 shirts, and 1 sweater to pack for a trip? Well, he's got 4 total pair of pants, and he wants to choose 2 of them. This is an AND case. We want it to all happen at the same time, so we're going to multiply. There's 7 shirts. He's going to choose 3 of them. 3 sweaters. It's going to choose 1 of them. So we're going to enter that all into the calculator. So we'll type 4, math, over to probability, choose option 3, enter the 2 times 7, math, probability, option 3, type the 3, hit enter, or sorry, not enter, times 3, math, over to probability, choose option 3, type the 1, hit enter. When you get this all typed in, you should find that there are 630 different ways that could happen. The next one says the general manager of a fast food restaurant chain must select 6 restaurants from 11 for a promotional program. How many ways can this be done? Well, there's 11 total. He's choosing 6, so it's just 11 choose 6. There's 462 different ways that could happen. Number 5, your friend is having a party and has 15 games to choose from. There's enough time to choose 4 games. How many ways can we do that? 15 choose 4. So on a graphing calculator, remember, you can just enter that 15, math, probability, option 3, 4, hit enter. If you're on a scientific calculator, it may or may not have these formulas stored in them. If they don't, remember, you can always just use the actual formula. 15 factorial over 4 factorial times 15 minus 4 factorial, and get 15 factorial over 4 factorial times 11 factorial. So you know everything from 11 on down divides out, so it's really 15 times 14 times 13 times 12 divided by 4 factorial, and you could enter it that way. But at any rate, however you're typing it in, you should find that there are 1,365 different ways that could happen. You must take 6 elective classes to meet your graduation requirements for college. There are 12 classes that you're interested in taking. How many ways can you select your electives? Well, there's 12 total. You're going to choose 6. And again, it doesn't matter about the order. They're all electives. So you just need to choose any 6. You should find that there are 924 different ways that could happen. Alright, playing cards. So remember that a standard deck of playing cards has 52 cards. Half are red, half are black. So there's 26 black, 26 red. There's 4 different suits: spades, hearts, diamonds, and clubs. So the hearts and diamonds are the red, the spades and clubs are the black cards. So because there's 4 different suits with equal amounts, there's 13 cards in each suit. Example A, if the order in which the cards are dealt is not important, how many different 5-card hands are possible? So we've got 52 total cards, and we just want to choose 5 of them. We don't care about the order, so maybe we're playing rummy, and we just need a 5-card hand. Doesn't matter in which order we get them, just what 5 cards they are. So in the formula, remember this would be 52 factorial over 5 factorial times 52 minus 5 factorial. You could simplify that down, or you could just type it into the calculator with the formula stored in the calculator. But you should get 2,598,960 different ways that could happen. What if we change it and we want them to all be of the same suit? Well, there's 2 different things we have to choose then, because there's 4 suits. So first thing we have to select is which suit do you want? Spades, hearts, diamonds, clubs. So out of the 4 suits, you're going to select one. Then, in addition to selecting that, you've got to choose 5 cards from that suit. So there's a total of 13 cards in the suit. You want to choose 5. So you're going to do 4 choose 1 times 13 choose 5, because this will get you the suit, so it'll select one of the 4 suits. Once you're in that suit, this will choose 5 cards from the 13 cards. And if you type that in, you should find that there's 4 options for the suits, which you know. And then there's 1,287 ways you can choose 5 things from a group of 13 things. So if you want both to happen at the same time, we use that fundamental counting principle, and we multiply 4 times 1,287, gives us 5,148 different ways that we could choose 5 cards of the same suit. Example 8. William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, and 10 are tragedies. How many different sets of exactly 2 comedies and 1 tragedy can you read? Well, there are 18 comedies to choose from. You're going to choose 2. And means fundamental counting principle. We want to multiply. We want it to happen at the same time. 1 tragedy, so 10, choose 1. And if you type that in, you should get, there's 153 different ways to choose the comedies, times 10 different ways to choose the tragedies, which makes sense. There's 10 options, and we want to choose one of them, so there's 10 ways we could do that. And so you'll get 1,530 different ways that you could read 2 comedies and 1 tragedy. Part B brings in something a little different. It says, at most. So this is no longer an and case, but we have several different possibilities we could consider. At most means no more than 3, but it leaves open the possibility of less than 3. So out of the total 38 plays, maybe we choose to read none of them. Or maybe we choose to read, 2. Or maybe we choose to read the maximum 3. We don't want this to all happen at the same time. It's not an and case. We're saying we could do this, or that, or this, or that. And when or comes into the picture, that means add. So if there's an or possibility, you should be adding. And the keywords to help you to know to do that are things like this: at most, at least. So we're going to add up these different possibilities. So if we choose not to read any at all, there's only one way to do that. We simply don't read any. If we want to choose 1, there's 38 different ways to do that, because there's 38 to choose from. If we want to choose 2, we're up to 703 different ways that can happen. And again, I just typed this into my calculator with the stored formulas to find these numbers. And if we choose to read 3, there's 8,436 options for how that could happen. So if I add those all up, 1 plus 38 plus 703 plus 8,436, I get that there's 9,178 different ways that I could read at most 3 plays. And that's considering all the options. I could read none, 1, 2, or 3. Alright, back to the deck of cards. So we're going to find the number of possible 3-card hands that contain the cards specified. Well, if we want 3 black cards, we have to think about how many black cards are in the deck. It's half the deck, so there's 26 black cards, and we want to choose 3 of them. So So if you calculate that, it comes out to 2,600 possibilities. Remember, this is your total. We're talking about black cards. There's only 26 total black cards. This is how many you want to choose. I want to choose 3. Number 10 says 2 aces and 1 other card. Well, there's 4 total aces and we want to choose 2 of them. And tells us to multiply. 1 other card means anything other than an ace. So if we think about the total deck, there's 52 cards, but we have to take out the 4 aces because we want something other than an ace. So that means we're down to 48 cards, and we're going to choose 1 of those remaining 48 cards, so that we're selecting a total of 3 cards. They want a 3-card hand. 2 of them will be aces, so out of the 4 aces we're going to choose 2 of those, and then 1's going to be something totally different. So out of the 48 other cards we choose 1. So 4 choose 2 times 48 choose 1. There's 288 ways we could get a 3-card hand that has 2 aces and 1 other card. Final example we'll do together. Find the number of possible 5-card hands that contain 3 of one kind and 2 of a different kind. Well, remember that kind means aces, 2s, 3s, 4s, etc. So there's 13 different kinds in the deck. First thing we need to do is choose 1 kind. So out of the 13 options, we're going to choose 1. Then once we're in that kind, there's 4. There's 4 2s, 4 3s, 4 aces, 4 kings, 4 10s, 4 jacks, etc. So no matter which kind we choose, there's 4 options, and then we're going to choose 3 of them. And that's going to take care of this part, 3 of one kind. So this part chooses the kind. Then once we choose that kind, there's 4 cards. We want to choose 3 of them. And, so I keep multiplying, 2 of a different kind. So there were 13 kinds originally, but I already chose one. Let's say I chose the 5s, and I chose 3 5s. Now there's only 12 kinds left, anything but a 5. And so I'm going to choose 1 of those remaining 12 kinds. And once I've chosen that, let's say maybe it's the queens. There's 4 queens, and I want to choose 2 of them. So that all together I'm choosing 5 cards from 2 different kinds. If you carefully type this all in and calculate it, you'll see that there are 3,744 different ways this could happen. So with combinations, total number, choosing how many, order does not matter, and you just gotta carefully think through, what do you need to select. So in examples like this where it starts to get more complicated, you first gotta select a kind, then from that kind you choose 3 cards. Then you gotta choose a different kind, and from that kind you gotta choose 2 cards, so you get your total of 5 cards. Good luck with combinations.